Perfect. Welcome all once again. This is day 12 of 100 Days of Hacking. We're going to be led by Amarjit Labhuram, who is going to be taking us through um, deeper into Active Directory. So without wasting so much time, let me welcome Labu. Please, Labu, take over the session.
Thank you, Jones. I hope everyone is having a good evening, night, day, morning, afternoon, wherever you've joined in from. My name is Amarjit Labhuram. I had done a previous session with the cohort, with this 100 Days of Hacking, whereby we had set up an Active Directory lab and we used bad blood to add more users and machines onto the domain. I hope most of you were able to follow along, or whoever was able to also watch the video recording that was shared on YouTube. You managed to set up your labs, and since I didn't get any questions, I would assume that people had smooth sailing setting up their infrastructure. Before we continue, maybe a little bit of housekeeping that I'll request for. Uh, at any given time, if you want to unmute your mic, you can stop and intervene me and ask a question. I will not be looking at the chats. I'll be looking at the chat at the end of my presentation. So for any questions that come in the chat, Michael, I don't know if you'll be with us through the session. If you are, you could stop me and ask the question that comes in the chat. If not, I'll try and answer all the questions at the end. And just to before we begin, maybe I could request by a show of hand how many people had set up their lab as per the previous session. Okay, so we have only one person. That will mean that to the rest of you, some of this may it'll be informational, but to practically test it, you'd have had to have already set up your lab prior to this session. Excuse me for a second. I'll be back just now. So sorry about that. Hi, sorry about that. I had a call coming in. Yeah, so I was mentioning previously, whoever has not set up the labs, it may be a bit challenging to do the practical side of what I'm going to discuss, but I hope you can set it up. For those of you who may not have enough infrastructure capacity, I've seen someone on the chat saying that they do not have enough RAM and hardware to be able to spin up labs. You could try and set up virtual labs on platforms like Azure or AWS so that you can practice, because otherwise then pretty much you won't be able to do the hands-on bits of what we're going to discuss today. For those of you who did follow along, Jones, there is an addition that I made to the lab. So what I did is I added a server 2012 machine just because of avoiding antivirus stuff on it. So basically what that does is, for one of the exploits or one of the attack paths we're going to abuse today, you will definitely need to set up a second. So at the moment, the lab was just a PC and a domain controller. I've extended that and added an extra machine. So I will, once we get to the practical bit, I will show what additions I've done and what changes I made so that you could set up the lab in a similar fashion. But basically, once we had set it up, we had put bad blood to populate users and other machines and create various misconfigurations in the domain that we can abuse. Cool. So starting off, today's session is going to be on Kerberos and basically what it is and the various attack paths or attack methodologies that could be used or abused around it. So this is basically an objective of what we're going to cover today. So we're going to do a Kerberos 101. We're going to look at AS-REProasting, Kerberoasting, Unconstrained Delegation, Constrained Delegation, Silver Tickets, Golden Tickets, and Skeleton Keys. So basically, from Kerberoasting, from AS-REProasting all the way down to Skeleton Keys, various abuses that can be done for Kerberos. And whatever is highlighted in white, we'll practically do it for today's session. Whereas whatever is in red, we'll either do it in a follow-up session, or I can leave it to the viewers to try on their own. And if they do find issues, they can always reach out to me. So, Kerberos. Basically, this is the three-headed god. Just as the name suggests, it's the three-headed god from Greek mythology. And this was the hound that guards the gates of hell. So it's an authentication protocol. So that's the definition, or that's the name, or where the name comes from, the Kerberos name. And basically, it's an authentication protocol, and mind you, very focused on specific thing, authentication protocol. It's not an authorizer. It does not give authorization to access things. It just authenticates. So Kerberos is an authentication protocol for untrusted networks. And it was actually developed by MIT back, I think, in 1993, if I'm not wrong. And then it was picked up by Microsoft and incorporated into its authentication mechanism for the Active Directory or Windows networks since 2000. Basically, prior to that, Windows was using the NTLM authentication protocol, but Kerberos gives a lot more, as we'll see, a lot more use cases and makes things work much more efficiently in a large network. Kerberos relies on tickets for authentication. So basically, these tickets contain specific information about either the user or whoever is trying to access stuff. And they usually tend to store these tickets in memory. So each ticket that we generate gets cached into your local machine. Basically, it's stored in RAM. So when you look at this diagram, this is basically the overview of how the Kerberos authentication happens. So there are a number of steps that occur whenever a ticket is requested, or a service or user tries to request for a service in the domain. And by definition, service could be various things. It could be access to a file share on the server, on the network. It could be accessing PowerShell remoting on a remote machine. It could be accessing maybe a web server on the network. So those are all various services, and they will be all running on a resource server, as you can see on the diagram shown. So what happens is the first step is called an AS-REC, which is an authentication server request. So the user sends a request from their machine to the Windows domain controller, and that bit of the authentication protocol authentication mechanism is the AS request. Now, the Windows Domain Controller usually comes pre-installed with the KDC, Key Distribution Center services, and that gives two mechanisms. There's the AS bit, which is the authentication server, and the TGS bit, which is the ticket granting server. So basically, the domain controller is the one that confirms authentication and provides tickets to access specific services. So when the first bit happens, the AS-REC, the user is basically requesting for a ticket granting ticket, which it'll then, if the response is confirmed by the domain controller, it will then send back an AS-REP. So that's in layman terms is an authentication server response, which may contain the ticket granting ticket for the user. The next thing, the user, when they want to access a specific service on a remote, on a different server, they will then use that TGT through through the TGS rec, which is the ticket granting service request, back to the KDC. And then if everything checks out, the KDC will respond with a ticket granting service response. After that, the user then can use now this received service ticket, which is with the TGS rep, and send it to the resource server. If the resource server checks everything is working as required, it will then give the user access. If not, it will deny the user. This is just a quick like diagram to showcase the whole thing, but we will go into each bit step by step. So as you saw, step one, which was the AS-REC bit, the user password that we store on our machine. So whenever we log in, we key in a password that is converted into an NTLM hash, which is then time-stamped and encrypted with this NTLM hash. And that's what is sent to the key distribution center to authenticate the client or the user. Then the second step is where we saw the response coming back from the server or from the domain controller or the KDC. Mind you, I will use those two words interchangeably because they ideally occur. The KDC is part of the domain controller. So if I say the domain controller or the KDC, just know it's one and the same, right? So basically, in the second step, the server sends back TGT with a session key, and that's the AS-REP bit of the response. So basically, the TGT is an encrypted signed. It's encrypted and signed. It's encrypted and signed with the KRB TGT hash of the domain controller, and returned back to the client. Then when the user now wants to access, let's say, a database server or a web server or a file server on the network, it will then do the third step, which is the ticket request plus authentication. So what this does is the client will then present its TGT back to the key distribution center to request for the service ticket. Say, as we say, we'll stick to one example right now. We'll talk about a file share. So the client sends their TGT back to the KDC requesting for file share access to a particular server on the domain. The KDC will open the TGT and validates the PAC. So a PAC is a privileged attribute certificate, and basically it's an extension of the Kerberos ticket. It contains useful information about the user's privilege. So this is where now the privileges that are stored in the AD's database is then used to verify that this user has the rights and has the rights to access specific services. So when the user used their Kerberos tickets to authenticate to other systems, the pack can be read and used to determine their level of privileges without reaching back to the domain controller, since the pack is already contained in the ticket itself. So there is no requirement for the authenticating service, so the let's say the file server, to go back to the domain controller to really ask what are the privileges this user has, because the pack contains that information. The fourth step in the cycle is where now the TGS, it's called the TGS response. So the server sends back the service ticket that is encrypted with the requested service NTLM password hash. Now, in the first one, we had the NTLM password hash of the user. When we get to the fourth step, we're now getting the NTLM password hash for the service that we're trying to request. So in this case, in the example of the file share, we will get the NTLM password hash for the CIFS service. CIFS is the file share service running on the server. So basically, it means we can sort of get authentication as this. So each step has some abuse part. If you're careful, you can start of trying to draw the maps of where the various abuses will take place. In the fifth step, there's a service request and authentication. So this is now when the user is going to the file share. So the client connects to the resource server, in our case, the file share, presents the service ticket for the file share service. The file share server will then open this service ticket with its own NTLM password hash. Once it can decrypt the ticket, it will then be able to see, yes, this user then has access. If everything checks out, as I said, step 6 is the server authorizes. So it sends an application. It's called an AP. Sorry, it's application service response. Sorry about that. So yeah, basically, it's the application response that comes in the last step. So that's where either the user gets rejected to access the service, so either an access denied, or if they do have everything checks out, they will be given access to the service. So uh, just going through it again without now using the technical wordings, this is how the whole chain works. For the whole A secret value needs to be used that can verify the identity of the client, and the default secret in a Windows network is the NTLM hash. So the NTLM hash is encrypted and used to request for a TGT, that's in step 1, from the key distribution center. Once the KDC verifies the request is coming from a valid user of that domain, it will issue a TGT to the client. So that's step 2. From there, the KDC, once the client needs to access a specific service, so our case was the file share on a different server, it then sends its TGT to the KDC and requests for a ticket granting service ticket to the specified resource, the file share. So that's step 3. The TGS tends to be encrypted with the service account password hash and is composed of 2 parts. One portion is the ticket itself that is sent to the resource server, and the session key, which the client keeps and usually has a validity time period. So that's at step 5, right? At step 4. Then at step 5 is the service ticket is then sent to the resource server. It is opened and checked by the file share, and it checks the pack within that service ticket to verify that this user has access rights for the requested file share. So just like how you can say specific users have only read access, some may have write access, and some may have read, write, and execute access on the folder there. So that would be contained in the pack bit of the service ticket that's been sent to that file share. Once the pack is checked, I mean, once the service ticket is decrypted, the pack is verified, everything checks out, then the server will respond with the authentication response. If we're to look at this practically, this is an example of the setup we did. So this was the user we had created, and at this point, the user is logging onto their machine. In the background, there are all these requests happening because basically Kerberos was designed to sort of formulate like a single sign-on. They didn't. You don't want, when you're managing or when you have a large network, you don't want the user, putting in their password every time they're requesting for a service. So you find that once you've logged into your machine, the moment you browse, let's say, to the web application server, it can use single sign-on authentication to authenticate you if it's been set up. If you're going, as I said, let's say to a file share, you will not need to put in your username and password. It will take the NTLM hash and do all these Kerberos requests in the background. So I have a Wireshark like output of now, this is the moment a user is logging into their machine. You can see there's a number of requests, Kerberos requests made. In my case, the IP 10.1166 represents the machine, the Windows 10 machine, whereas 10.1150 is the domain controller or KDC in this instance. And you can see the responses, the requests and responses sort of, they go in the same logical flow that I had shown in the diagram. So you can see, and there's an AS request made first, then an AS response from the server received, as you can see, the source and destination. So you can see there's an AS request made from the Windows machine to the server, and then the server responds back with an AS-REP, which is the TGT is sent now back to the user machine. And then the user can now do a TGS request for any particular service they would want to request on the network, and a TGS response comes in. So this whole chain is the first four parts of the Kerberos authentication mechanism. So at this point, the user has not gone and requested for any other services beyond just logging onto their machine. So this was actually, when you're logging onto your machine, there is a request to access host. So that's why this whole authentication process happens in the background, because also as you're accessing your machine, your user interface, your desktop environment, these Kerberos authentication protocols are running in the background. If we're to open out these in Wireshark and try and read out what's going on the AS request, which is the first bit of the process, as you can see, which is highlighted there, there is a pack that is, there's a pack request that's made. And as mentioned earlier, the pack is basically all the various information about the user and what rights they have to what sort of rights they have on the network or domain. In the S response, this is what's coming back from the server. We have two key parts that we can see. The first one is the ENC, basically the ticket itself. So this ticket is the ticket granting ticket. And you notice that in the sname string and in the sname string, there's the KRBTGT secret key that's used to encrypt this ticket. The below part, which is the ENC part, is the ticket granting service session key encrypted with the user's secret key. That's now the one who is requesting this TGT. So basically, if we request for an S-REP, we can get the secret key of the user. Remember that bit. Then the next bit was the TGS request. So this is now when the user is now sending a request back to the KDC for a service ticket. So the ticket, if you the key parts, again, this will all contain the TGT, as you can see highlighted in the upper portion. and the lower part is the actual service that we're requesting the ticket for. And as mentioned, since this was user login, the service that we're trying to request for is the host service. And this host service is running on the PC we are logging on, which was PC01, which was based on the previous session we had. Then the next bit is now the server responding back. So this is now the next, the last bit where the server is now sending back the access to that host service that was initially requested for. And the enc part again, at the bottom, contains the server session key encrypted with the ticket granting service session key. So all this stuff is encrypted, and that's why the whole making it very difficult to like try and uh, just abuse getting these these encrypted details without trying to understand what's going on. So it's easy once you start mapping out, you can start seeing where the opportunities are for abuse. So this was just the whole protocol when a user is logging onto their machine. It may not be very interesting to us because it still may not make a lot of sense. So what I decided to do is, as the example used before, I tried to access, once I authenticated to the machine as the user John Doe, who is a normal user on the domain, I tried to access the C drive of the domain controller. And because this is a normal user, I should not be able to access that, which, as you can see in the screenshot, I got an access denied. Now, if we're trying to look at that through Wireshark, we can see that there's a new service ticket request that was made for the CIFS service that's running on the domain controller. And after that request and response was received from the domain controller, there was some SMB traffic as well. As you can see at the bottom, some sort of session setup, request and response. So we'll go again a little bit into this. So the initial part was the first part, as you can see in that, was the TGS rep. So this is the ticket granting service response for the CIFS on the domain controller. So again, this is using Wireshark. When you open and try and read through the request that was made, you can see that it's a TGS rep, and it was asking for the CIFS service on the dc.acme.local, which is the domain controller. From there, there was an app request for CIFS on the domain controller. And if you again open out this in Wireshark and try and read it out, you can see that there was a ticket that was sent back from the domain controller for the CIFS service that's running, of course, on itself at the moment because we're using the same machine. And there's the authenticator bit because basically the domain controller is the authenticator in this instance. When you then open out the application response for the CIFS on the domain controller, you will then be able to see two parts again. The key part is the encrypted part, which is the whole, this will be the encrypted hash for the file share service running on the domain controller. So if it was successful, we would have gotten an encrypted. But basically, since there was an access denied, yes, we do get an app rep from the server, but then since the pack indicates that Windows does not have rights to access that C dollar, that app rep will then also contain the piece of data that will give us that access denied error when we request for the service. So what we have seen is that tickets is the main thing that Kerberos works around, and two key tickets that we will be working with are the ticket granting ticket and the service ticket. So some elements to keep in mind are tickets are renewable and reusable. So if I request for a ticket for the CIFS service for the domain controller and I did get a success, access, then that same ticket, since it's stored in memory, every time I would go and request for the file share server on that same server, it will use the ticket that's stored in memory. So that's where the reusable bit comes about. Now, the renewal bit comes about because there is a time limit also when you're dealing with tickets. So that's why the whole timestamp comes into play, so that it validates and allows a ticket to be used for only a specific period of time. It's a safety mechanism so that a ticket cannot just live unlimitless or life or forever to be used or abused in the domain. And of course, the service ticket checks if the principal contained in the ticket has the privileges to use the services requested for in the ticket. So, sorry, I jumped ahead. Sorry. When you so once you have your tickets, as I said, it's time barred and can be reused. When you present that service ticket to a domain control, I mean not a domain, a server that's running a particular service, it will be able to decrypt the ticket, confirm the validity of the ticket based on the timestamps, and then check if the principal contained in the ticket has the privileges to use the service requested for. So that's where I, as mentioned previously, that the KDC is an authentication server, whereas now the service is doing the authorization bit. So are you authorized to access the specific service that you're requesting for? Another key bit to keep in mind is SPN, also a short form for service principal names. Basically, a service principal name is a unique identifier of a service instance, and SPNs use Kerberos authentication to associate a service instance with a service logon account. That may sound like a mouthful, but we will look at it in the practical side when we go ahead. But in essence, an SPN is the mapping between a service and an account. So you could have, for example, let's say you're running a MySQL Microsoft SQL instance on a server. You could then link that to a particular account such that like with MySQL, there's an SA account, that's the administrator account for the database itself. But to request for services that the database could be running, you can create an account and link it using an SPN. So that's what it does, the mapping between a service and an account. And then that account can then be used by users to request for particular services, particular stuff from the database. The client does not need to know about SPNs, but the key distribution center does, so that it can properly encrypt the server portion of the service ticket. So say the client wants to communicate, as mentioned, to the SQL server on let's say server 1. When a request is made to the KDC, it knows that it needs to map the appropriate service account in the which in this instance would be the SQL service, as you can see on the the slide that's shown there. And using its NTLM hash, it will encrypt the ticket granting service ticket that is sent back to the client to then forward to that SQL service. So the format of these SPNs tend to look like service class, then the host and the port that the service is running on, and the service itself. So as mentioned earlier, we have a SQL service here running on server 01 or the port 1433, and it's of course you can, and these naming conventions can change as per your needs when you're setting up these things. A simple command to list out all available SPNs in a domain is shown there, which is set SPN -q */*. And this basically will query the KDC for any accounts that have an SPN set on it. So we get into the attacking bit of the Kerberos authentication protocol. Now, the first attack that we see is Kerberoasting. And basically, it involves requesting the TGS from a Windows domain machine, and then as you get, okay. So let me restart that. Kerberoasting initially was discovered by Tim Medin in 2015, and it involves getting the passwords of the service that's running of the service that's running on that SPN. So basically, when a service is running on a machine under the context of a user, so what we talked about previously, the SPN, these accounts are either local to the machine or are domain accounts. SPNs are used with Kerberos to authenticate service instances with a logon account and are configured on the user object in AD. So this, when you're setting up an SPN, it's usually assigned as based on the user object. And as from the previous session, we if you recall correctly, an object can either be a machine or a user on the domain. So keep that in mind as well. So part of the service ticket returned by the KDC is encrypted with a secret derived from the password of the user account running that service. So we saw that we have uh, a service here in the previous one called SQL service. So basically, as we spoke, as mentioned just now, the password that will be encrypted in that service ticket will be for the MS SQL service running on that instance. So basically, with the whole technique in play, if an account has been set with a weak password, an attacker can request for a ticket granting, a service ticket, TGS ticket, take it offline and try and crack the services encrypted password and get a clear text password for it. Then the next attack will that's there is the AS-REProasting. So typically, during authentication, as we saw in the whole Kerberos authentication mechanism, the initial two steps was an AS-REC, which is request, and there's the AS-REP, which is the response from the server. Now, the initial request that is sent contains the ticket granting ticket of the TGT from, okay, let me just start that. So the initial authentication stage, a user requests a TGT from the KDC in the form of a AS-REC packet. If the account exists, the key distribution center will return the ticket granting ticket encrypted with the user account's credentials. Remember, it took the NTLM hash credentials, meaning that only a valid user or machine possessing the valid credential is able to decrypt the ticket. Now, if a user does not have Kerberos pre-authentication enabled, an AS-REP can be requested for that user, and part of the reply can be cracked offline to recover the clear text passwords. So the whole essence of this attack is where there's a situation where the first airstrip is not part of the process, meaning the user does not require to authenticate to the KDC. Now, there are certain instances where this could be found, especially where Unix servers are part of the network and is part of the domain, because the way the Unix operating system works, these passwords are not stored the same way like on a Windows machine. So you find sometimes that for Unix systems, an administrator could set it that it does not require pre-authentication. So that's where this attack becomes ripe for abuse. Now, before we go to the next parts of the attacks, Kerberos was also brought about, aside from just as mentioned previously as an authenticator, it was designed to give a lot more usage, whereby usage in the sense there's a term called single sign-on. as mentioned earlier, that a user does not need to repeatedly keep putting in their password to access various services. So that's one area tackled. But now imagine a situation where a user wants to access a web server that's connected to a database server. So instead of the whole authentication happening to the web server, then again, the whole cycle going to the database server, delegation was brought about. So what happens is in step one, the user provides the credential to the KDC, like the normal AS-REC. Then part two is the KDC returns the TGT, which is the AS-REP. Part three is the TGS-REP. So the user requests for a TGS to the web application on the web server. The KDC provides a service ticket to the client, the user, which is in step four. Now the client can present that service ticket to the web server, which is in step five. At that point, which is in step six, now the web server has received the service ticket for the web service, but as the user is interacting with this web application, there's also requests made to a database server. So before the user can access the data that's in the database server, the sixth step comes into play, which is where the delegation happens. So the web server service account uses the service ticket that was used to request, uses the service ticket of the user to request again for a service ticket to access the database server as that user from the distribution center. So that's the sixth step. Once that is received, it is stored in the memory, or it's relayed back to the database server, depending on what sort of delegation has been set up. But just keep this diagram in mind, because we will speak of the various delegations and how this comes into play. So the seventh step is then where the web application can now connect to the database, because it has the verified service tickets for that user that's requesting the service. The third, so we're now, as mentioned, delegations, there are various types of delegations. So the first one is called unconstrained delegation. So unconstrained delegation allows a user or a service to act on behalf of another user to another service. So as given the example of the web server service, acting on behalf of the client that requested access to the database server. So a common implementation of this is where a user authenticates the front-end web application serves a backend database. The front-end application needs to authenticate to the backend database using Kerberos as the user. So we understand how a user performs Kerberos authentication to the web server, but how can the web server authenticate to the database and perform actions as the user? So that's where unconstrained delegation was the first solution to this problem. So if unconstrained delegation is configured on a computer, the key distribution center also includes a copy of the user's ticket granting ticket inside the service ticket. So in the example of the web server, which we saw in this slide, when the user accesses the web server, it extracts the user's ticket granting ticket from the service ticket that it receives and caches that TGT in memory. When the web server needs to access the database server on behalf of that user, it then uses the user's ticket granting ticket, which we saw here as step 6, to the KDC to request for a service ticket for the database service. So an interesting aspect of the unconstrained delegation is that it will cache the user's TGT regardless of which service is being accessed by the user. So even if, like in the previous, in the diagram, we were talking of the web service, if unconstrained delegation is set up on that web server, even if a user requests for file share, their TGT will be stored in memory. So that becomes a very dangerous scenario, because basically that server, or that server is technically storing ticket granting tickets for various users that access any service on it. So if you compromise that server with that has unconstrained delegation, you can extract these TGTs and use them to impersonate the user against other services in the domain. So we will actually look at this practically and see how we can uh, perform another attack called DC Sync once we are able, if the demo codes work with us, if we're able to exploit the server that has unconstrained delegation set up on it. So to sort of fix that issue, because I mean it's dangerous that any ticket, any service that's requested for, irrespective of whether that ticket, the TGT is required for that user to be relayed for further use. Microsoft came up with a workaround for this, because as mentioned previously, unconstrained delegation allows servers to authenticate to resources on behalf of the user that's requesting for the service by taking that TGT alongside with the service ticket, uh, and it keeps on storing this TGTs in memory. Now, when it comes to the constrained delegation, it's the the okay. So when it comes to the constrained delegation, the aim was to restrict the services to which the server can act on behalf of. So, for example, that web server has a web application running on it, and maybe it has a file share running on it. So let's say it has just those two services. The constrained delegation can be applied specifically to the web application bit of it. So, for example, if a user then tries to access the file share, but they're not accessing the web application, their TGT will not be stored in the memory of that machine. So, to be able to work out and like lock down that TGT is only stored for specific services, the constrained delegation was what Microsoft came up with, and it uses two extensions. There's one called S4U to self and S4U to proxy. Basically, this limits the type of services a particular machine is trusted to delegate, trusted for delegation, and can actually access on behalf of an authenticated user. So as mentioned earlier, if the constrained delegation is set purely on the web application, that's the only service that can use delegation to act on behalf of the user. The CIFS one would not have that. So it restricts the type of access, delegation access that is given. Another attack that is commonly seen that abuses Kerberos is the silver ticket. And silver tickets are essentially forged service tickets, which grants access to particular service, aka the service tickets. So if I was an attacker and I gained access to a computer running a service, and I elevated myself to maybe an admin, I could dump the NTLM hash of the respective account, that is either the computer account or user account, and generate a silver ticket impersonating the said user or service. With this said generated ticket, I could then employ maybe pass the hash, pass the ticket attack, or inject the ticket into my current session and access other available resources. So silver tickets are created directly on a compromised host. There's no requirement for ticket granting ticket. So the first two, the SREC and SREP does not come into play. There's no ticket actually being requested from the key distribution center, because we're abusing the service itself. So we're actually communicating with the server that's running the service. So again, the KDC does not come into play. So the third and fourth step of the Kerberos protocol mechanisms do not come in. That's the TGS request and the TGS response. And the target server does not even verify the tickets with the key distribution center, because it's coming from a valid source. So that's how how the impact that a silver ticket can have when it's set up. So in order to generate a silver ticket, you require the NTLM hash of the service account. And typically, services run under traditional user accounts with an SPN. So examples are there: MS SQL, IIS user. They're much more. You'll see various implementations in different environments. So if the silver ticket was dangerous because it gives you access to any service on the domain, if you can abuse the TGT of a service account, then golden tickets are taking it even to a higher level. So imagine if you could forge a Kerberos ticket that would grant you access to any resource on the network at any time, even as much as forever. Remember, we talk about Kerberos tickets having um, time limitation, but a golden ticket can be forged to be almost limitless. I've seen, I think by default, if you're using the tool Mimikatz to generate a golden ticket, the default time value for valid the default value time frame that the ticket would be available is 10 years. So if a network is compromised, I mean a domain is compromised, and the attacker creates a golden ticket, and there are certain things that need to be done to be able to protect the domain. So if the KRBTGT password is not reset, in fact, it needs to be rolled twice, that golden ticket can be valid on that domain for the next 10 years. So that gives persistence to the attacker. So anytime they can get a foothold back on the network, they can get the privileges or maybe an admin, depending on what sort of golden ticket was forged. Um, so yeah, a golden ticket requires the KRBTGT password hash, which is a specific account in the domain. It's a particular account on the domain. And if that account gets compromised, as mentioned earlier, it's what's used to forge the golden ticket. It's also the account that's used to encrypt all the ticket granting tickets of the domain. So it's a very crucial account. Once the KRBTGT account is recovered, or maybe the user, I mean, the attacker gets that, there's the golden ticket basically just requires the attacker to then know what's the domain name, the domain SID, security identifier, and you can provide it with the user ID for who you want to impersonate. And that's how, once you have those three and using, as I said, a tool like Mimikatz, you can forge a golden ticket to impersonate any user on the domain and have certain privileged access for a specific period of time. You can forge these tickets with time frames and all that, but the default, as mentioned earlier, will generate a ticket that's valid for 10 years. The last attack within Kerberos that we will discuss for today is the skeleton key attack. Where the skeleton key attack is used, both NTLM and Kerberos methods are tampered with. Now, just to go back a little bit, Kerberos was introduced, I think, in as mentioned early in 2000s, and previously NTLM was the authentication mechanism used. So by default, even in today's implementation of domain controllers, Kerberos is the primary authentication mechanism. If Kerberos fails, the fallback authentication mechanism is NTLM. So when you're using a skeleton key attack, it basically abuses both authentication mechanisms, NTLM and Kerberos. So, for example, during an NTLM authentication, the hash of the master password that has been injected inside the LSAS process, this is where now when you're logging in to your machine, your credentials, like we saw in that previous slide, when you authenticate, your credentials are then stored as a hash, as an NTLM hash in memory within the LSAS process. And that's not compared with the SAM database that's inside the machine. But with the skeleton key attack, the hash which is in this is the same as the authentication that was used. It will succeed. So Kerberos encryption will also downgrade to an algorithm that doesn't support salts, which is RC4 HMAC, and the hash retrieved from the active directory will be replaced with this skeleton key hash. Therefore, the hash of the master password will always validate the server side, and authentication will be successful for both methods. So whether you try to authenticate, downgrade to NTLM to authenticate, or use Kerberos, once the skeleton key attack has been done, you will be able to authenticate irrespective of the authentication mechanism being used in the environment. Um, Again, skeleton key is implemented in Mimikatz. So the tool Mimikatz is widely used for doing these various abuses, especially Kerberos abuses. And another tool that's used for Kerberos abuse is Rubius. So those are some of the tools that we will be working with for the practical bit of today's session. That ends the whole kill me by slides part of the presentation. I'll just quickly check if they have any questions. Generally, SPN uses KDC technique. KDC is not a technique, Meshach. KDC is the key distribution center. It's actually the domain controller, which is running two services. That's the AS, which is authentication service, and the TGS, ticket granting service, which now grants tickets for various services. That's there. An SPN is basically a user account. It could be now a user in the context of a machine, or the user in the context of a human that has access to specific services on the network. So that's how an SPN is assigned. I gave the example of SQL service running, and let's say there's a particular user we call MySQL. So you can create MySQL as a user on the Active Directory, and then create an SPN to the SQL service instance. I hope that is clear, Meshach. Okay, so we'll jump into the practical side of it. So the first thing we're going to do is we're going to try and abuse AS-REProasting. So let me just share my machine again. If anyone can let me know if you can see my screen. Can you guys see my screen? Jones? Okay, thanks. Cool. Okay, so I assume you can see my Windows machine. Just 1 second, I need to block this thing. So I have the Windows 10 machine that we had set up previously. Just don't mind the stuff that you see on the desktop. I just added this for some other tests I was doing. So to proceed, as mentioned, this is not anything about antivirus bypassing and all that. So I've cheated a little bit. I've disabled Windows Defender so that we can run some of these tools, because of course there's the tools like I mentioned, Mimikatz and Rubius are known to be malicious. So basically I've just gone and turned off real-time protection and cloud delivery protection from this machine. Okay, come on. Another thing, I then went and created a tools folder in the C drive of this machine, and I put the tools that I'll be using for today's session here. So some of the tools that we'll use are Hashcat to crack hashes. There is the AS-REProast PowerShell script. This is used to identify any users that may have the pre-authentication disabled so that we can request for a TGT for that user and try and crack it offline. There is the domain password spray. If we do get a credential and we want to try and do a credential spray and see which are the machines the user can access, there is that script. The MS-RPRN tool is basically used to coerce. It abuses the printer bug issue that's found in Windows. It's an issue with the print spooler, and basically using that you can coerce authentication from a remote machine as for a specific service on another machine. Then you have PowerView, which is we used it I think last time as well to enumerate users. It's basically it's an enumeration tool, PowerShell based. And then we have Rubius, which I mentioned previously. It's used for Kerberos abuse. And then instead of Mimikatz, I'm using Sharpcats. It's basically a modded version of Mimikatz. You can check it out if you just Google Sharpcats on GitHub. You should be able to find the repo where it's done, made from, and do what you need to do from there. So these are the main tools we'll be using for the session right now. And the first bit is as mentioned, is we're going to do AS-REProasting. So we will use the AS-REProast tool. PowerShell script, this one. So we'll just quickly run PowerShell with it. If you don't run it with bypass execution, it sometimes may not allow you to load scripts. Sorry, my machine is hanging. I have no idea why. Come on. Run that again. Hey. Sorry about that. I'm not sure why. Okay, there now. I hope this doesn't keep doing this because it's going to take us a long time to complete everything. Okay, so let's see if we can load the script. Oh my god. That's yeah. And yeah, that's that post. Sorry. Okay, so once the tool is loaded, we can do get help. Ay, ay, ay. So basically, it gives us how we can use this. I'll just go ahead and run that. Roast. So it gives us a list of users that are potentially we can that have that the what do you call it, the pre-authentication disabled, and this was also populated when we set up bad blood, so this automatically happens. And in this particular case, I'm going to be attacking this user because there's a reason I've done that. So we want to abuse for this, get the TGT for this Rupert Travis user. So the next bit we can use hashcat. I mean Rubius to get the tickets for this the users. And mind you, I'm not going to be talking about OPSEC requirements for red teaming and all, because if you do these tools out of the box running like this, there's a high chance you'll be caught if it's a mature environment that has EDR. There are ways of using the tools and generating less noise. I leave that to the users to or viewers to go and discover. But basically, what we can do now is use Rubius. So do tools. Yes, roast and format hashcat. Yeah, roast format hash. Because I'll be using hashcat to crack these passwords. So basically, why is it refused? Okay, let me just do that again. Hey, come on. Okay, yeah, sorry, I've added a forward slash before that. So this will now go and request for all the S-rep hashes for the users that have the pre-auth setting enabled. And as I mentioned, because if you run like this, you remember it's going to request for so many users that it found that if an EDR is in the environment, it can detect multiple requests being made. So one way you could do this is request tickets one by one for each user. Because of time, that's why I said I'm not going to go into that, but that's one of running this to not get detected as much is by requesting ticket for each user that we find S-rep roastable from the previous enumeration we did. And as mentioned, the person that we'll be targeting is called Rupert Travis. So I'm going to take this hash and copy it into Notepad. And we'll just have to align all this into one. If we have everything in one line. Okay, I'll need to now switch back to my host machine because to run hashcat, it requires GPUs and CPU processing, and I know my VMs will not be able to push much. So just give me a sec to switch over and then we can continue. This. Come on. Tools, hashcat. run. Okay, let me share my screen again. Can you see my command prompt? Okay, yeah, I can see it's there. So basically what I've done, I have copied the Rupert's hash into this, as you can see here. I've created a file called rupert.txt and I copied the hash from the Rubius output. And to now use this to use hashcat to crack this, we'll use hashcat minus m, which is the module we want to load. In this instance, we're loading the AS-REP, which is the M18200. M18200. Then we supplied the Rupert file and the dictionary. In this instance, I'm just using the raw queue. That's why I said I'm particularly attacking this specific user. We could have taken all of them and tried, but then just to save on time, I know this user's password is in the raw queue list, so I can use this. So once that runs, oh wow, it's exhausted and it didn't crack it. Did I use the right user? Okay, but basically this would be the steps you'd have taken to be able to then crack the password for the user. If we did, so that now tells you again that aside from just getting the encrypted hash, you also need to use a word list. And that means that if you're lucky that the user's password is in that word list, then you should be able to crack it. So in my instance, as we've seen, I thought I'd changed the password. Maybe I reset my lab at one point. So that's gone. I don't want to go and do all that process now. So to save on time, we'll just move forward. But basically, those are the steps. So once you've checked the users that can be AS-REProastable, you can then request for tickets to suggest going one by one for each user. Not requesting all of them at one go, because that can create weird alerts in an environment. And then the third step is once you have those encrypted, you have those hashes, you can then use hashcat with your dictionary table to then try and crack it. And that's the first part. So I'll stop sharing and go back to our Windows machine for the next bit. We're going to be doing Kerberoasting. Yeah. Why is it giving me the Windows 10 machine? Virtual box, command prompt, okay, cancel. Share, window, oh, it's not giving me to share that machine again. Okay, I'll just share the entire screen then. So that was the hashcat. We'll switch over now to back to the Windows machine. So this is done. I'm just going to minimize that. And we're going to now do the Kerberoasting. So for Kerberoasting, again, we can use Rubius or Hashcat to I mean, not Hashcat, Rubius or PowerShell to enumerate. Just give me 1 second. Perfect. It should get me the PC. I hope that's showing. Yeah, okay, awesome. So the PC is there. So as shown in the slides, we can look for SPNs that are there on the domain. So we can just use the shell, set SPN minus Q star dot forward slash star. And this will give you a list of all the various service principal names that we have in our domain. So this KRPDGT is usually there by default because that's for the domain. As I said, this is an account used by the domain. But then you can see other services. So for example, PC01, which is this machine, there is the host service, which remember we requested for this when we authenticated to this machine. So this automatically happens. It gives us an SPN for this machine. Then these are other SPNs that are there on the domain. So we can look into each one of these and see how we can abuse them. There is one that's here for a server SRV01. So this is what I had said earlier, that I added a new machine on the domain, which is running Windows Server 2012, just specifically because I didn't want to deal with AV while doing the demos. Once we have the SPNs, we can now start looking into users that we can try and request for their hashes and try and crack offline. So as mentioned, we can use PowerShell to do this, or we can use Rubius. So just for time's sake, I will continue using Rubius. Come on. So again, the syntax is yes, Kerberos. And again, as I said, this can be dangerous because you're requesting for all these tickets at a go, so it can be detected. But this time, we'll just take this first one for this user called Maj Turner and see if we can try and crack it for later abuse, because this leads into the next part of the abuse that we will show on this session. So I'd already generated this and copied it to my Windows machine. So again, I will stop sharing this one, switch over back to my machine so that we can crack with the hashcat. So if I do, basically that's the ticket we saw that we got from when we requested Kerberoasting using Rubius. So we will use hashcat. But this time, the module we're loading is for the Kerberos, which is now 13,100 or 13,200? 13,100. And then supply it with Maj's hash. And again, I'm going to use RockU. Yeah, and this time at least we have cracked the password, and the password is my password 123 hash. So at least we managed to crack one user's password that we didn't have in the domain earlier, and that's this user, Madge Turner. So how can we leverage this and continue abusing it in the domain? So that's basically Kerberoasting in simple terms. What we did there was what do you call it? we coming back to this. Right. Right. Yeah. So basically, we enumerated SPNs that are there. As I said, we could have gone one by one as per that list. Using Rubius, we just set it to Kerberos and it went calling various users and checking if they are Kerberostable. Gave us the hashes, took these hashes. So that's I say you can take each one of these and try and crack them using hashcat the way I showed. And of course, if the password does exist within the dictionaries you use, then definitely you'll get the clear text password. If you use weak or small dictionaries, uh, or if the user is using a hard password and a complex password, then there's high possibility that it will not be cracked. So again, that's why the whole essence of using complex passwords when enforcing users to use complex passwords in domains. It makes these steps, at least, even if it's abusable, as long as the user has used a difficult or complex password, it will not be crackable. So that's the advantage you'd have with that. So that was Kerberoasting. And now let's say we did find this user's password. So I'll just open another PowerShell screen. I hope it does give me issues. Okay, cool. So with that, with the knowledge that we have Madge, she's called Madge what? We have this Madge Turner and we saw the password was my password 123 hash. We can try and see. So this is where I was saying you could try and do password spraying and seeing where this user has access, maybe privileged access and all that. To save on time, I've set up that new server with this particular user as a local admin because we're going to then do the unconstrained delegation attack on that server 01. And so therefore we can just first set up remote accessing for that server as this user. So to do that, we will just use some PowerShell foo. PowerShell, so you can use this command, $password. So basically we're setting a variable to be equals to convert to string that password we got as plain text minus force. Then we're then going to create set up the credential to be for the particular user we managed to attack, which is the Madge Turner user on the domain ASME. And we're going to then want to remotely access the server 01 machine. So for that, we will again set that as a variable. So we're going to say a new PowerShell session to be opened on this server 01 using the credentials that we supplied that are stored here. So if we do that, is that machine on? Okay, sorry, I need to turn that machine on. So just give it a sec. This is definitely going to fail because the machine is offline. Yeah. Okay, so the machine is booted up. Let's see if we do this. WinRM cannot process requests needing cover there time difference between the client and server. So this is where we talked about the timestamps, and that this is where the time element comes into play when you're dealing with Kerberos, because if the times are different between the machines and the servers, it can create all sorts of issues authenticating. That machine has synced its time, so now you can see a new PowerShell session can open. So I can just do enter PS session, give it the name AS-REProasting, and you can see now I'm connected to the server 01 machine as the user, Mage Turner. So if I do who am I, you can see it's Mage Turner. If I do host name, I am on that. So I've remotely connected to that machine. And if I do who am I priv, as mentioned earlier, I had to make sure that this user was a domain administrator on this specific machine only. The reason for that is because to be able to access remember we talked about unconstrained delegation is whereby the TGT of every request made for every service, the TGT for every user that requests for a service running on that machine is stored in memory. So basically, as explained previously, LSAS is the process which stores credentials in memory of Windows machines. And to be able to access LSAS, you need to have administrative privileges. So for this lab, I have purposely made Madge Turner an administrator on that machine so that we can dump out, what do you call it, stored credentials that may be on that machine. So to abuse this further, we will, maybe I can just copy, let's see, what do I need to do? Yeah, actually, do I really need? So I'm just reading my notes quickly over here. Okay, so what I'm going to do is I'm not going to dump the credentials for this one from memory. We are actually going to coerce a ticket to be received while we're running Rubius on this machine. So I need to copy, first of all, let's enumerate and ensure that this server 01 is a machine that is set up with unconstrained delegation. So to do that, we will leverage PowerView. So I'll just come back to the machine we were on. Go to PowerView. So once PowerView is loaded, we'll use the get domain computer unconstrained and explicitly select the DNS host names. So it gives us that, and you can see. So the domain controllers are always set on unconstrained delegation, but are not abusable through these attack paths, because you then have to have at least administrative access on the domain controller, which in our current situation we don't have. But from our user, we get that Madge Turner account. We cracked her password, and we know that she has administrative access on server 01. That's why I set it up particularly this way in this lab. So we know server 01 is ripe for abuse for what do you call it? The unconstrained delegation attack. So what we'll do next is we're going to copy Rubius onto that server, and we're going to run it in a particular way whereby it's monitoring for tickets that it's receiving. So to do that, I'll go back to this one because I had set up, actually back to this one because we set up, yeah, we've set up this here. So we're going to use this command. Come on. Directional on that. Okay, it's refusing to copy. I'll just type it out. Copy. Come on. One. Path to file. This. The destination should be that is accessible. And that copied. So now we can go back into that PowerShell session. So if we do RC, this see it says copied, so we're good to go. So the next thing is we need to set up Rubius in monitor mode. Public, and then we run this. In monitor mode, so monitor, then the target. Come on. Target user, sorry. Target user is the domain controller. It's local. And sorry, not that, it's DC dollar. Because that's going to be the machine account for the domain, that domain controller. So we're trying to get the hash for that machine account. And what else do we need? We need an interval of 5. And the last thing we need is to wrap it. No wraps, actually, sorry. So you can see Rubius is now running in monitor mode. So this is where we now use the printer bug to coerce the domain controller to give us its hash. So just run CMD here again. Tools, AS-REProasting. And then we're going to coerce. Now this is where we needed the full parts. So basically we're going to give it the target and the server that's listening. And if once I enter this, let's see if we get the TGT for the domain controller. The network address is valid. Okay. Is it local? That all looks good. Sorry, I had not tested this out prior to the session. I think I reset my lab and this might have been broken as well. Because ideally, what we're trying to do is we're going to try coerce the domain controller to authenticate to this server 01. And since we know the server 01 machine stores, TGTs, it'll basically store the TGT for the domain controller machine account. Let's see if I do ping dc.ac.local. That's working. Sorry. Okay, so has that machine gone down again? I'm just logging on to that server 01 to see what's going on. It seems to be having an issue. What is it? Let me just turn off the firewalls for now and see if that will help. Okay, so at least that's working now. Okay, so you can see that worked. Sorry, it was the firewall that was on that machine. So another thing to show you that your firewalls can block this kind of an attack. So you can see the attack has run. The Prince Pooler was able to coerce, the MSRPN tool was able to coerce the domain controller to authenticate to this machine that has constrained delegation. And since Rubius was running in monitor mode, we were able to get the TGT. You can see it's monitoring for TGT for the domain controller itself. So this is the ticket granting ticket of the domain controller. Now, this is the steps we're saying we don't really need to try and crack this. You can also relay tickets. So to do that, we will again leverage Rubius, but this time from our machine. So I'll just copy this here to Notepad. When it does this. So basically it's supposed to be in one single line. I can now stop this running on the target machine, on the other server. Exit out of this, I'm done with you. So we're going to come back to Rubius here. And to check the tickets that we have for the current user, just clear this. You can use klist, and you can see the tickets we have for the current user that we are, which is John Doe. Quite a number. So we have the John Doe for the KRBTGT that we have John Doe again for KRBTG. We have John Doe when I was trying to access the CIFS ticket, which didn't work. This is for mail on a specific server. This is again mail. So you can see the tickets keep collecting and populating as we request, and all of them are for the user John Doe. Now we want to actually use this ticket that we have obtained of the domain controller to be able to then authenticate directly onto the domain controller, or probably do like a DC sync attack. So for that, as I said, I'll leverage Rubius and use the pass the ticket attack. So let's see, use Rubius PTT. And then this is going to be the ticket for that we just obtained. Not just it's a whole thing. Come on, copy and paste. It's not done it the proper way. Let me just edit this 1 sec. Come back to this. I don't need this now. Don't save. Clear this. Yeah, that's fine. Until it's error out. Clear this. So now I can do yes. Pass the ticket with what we have obtained. And you can see it says the action import ticket successfully imported. So if I do klist now, I should also see that I have the ticket for that DC dollar. Now, once that is in place, basically I have the TGT of the domain controller. That now gives me full access to try and exploit the DC sync attack. So to do that, I'll leverage shortcuts. And this is what the command would look like. Again, keylist just to show you that it's there. So basically, I'm using the Mimikatz version of Shortcuts version of Mimikatz. The command is I want to do a DC sync, and I want to obtain the hash for the NTLM hash and the AES-256 encrypted hash for the user KRBTGT on this domain. And the domain controller that I need to get this information from is the DC, asp.local. Let's try running that. Is that recognized? Oh, sorry, I made a mistake here. It's supposed to be C tools. And there we go. So I can actually now dump out passwords from the domain controller. So remember to do a golden ticket, this is the account we needed to get. And here we have the NTLM hash, and we also have the AES-256 encrypted hash and the AES-128 hash for that account. And this is not just specific to this BTGT account. Let me just see if we loaded Power View here. You can see these are all various users that it's populating. I should have done. Okay, so let's just take this Tamika Sanchez. It's the last one. So I can also do a DC sync to get the NTLM hash for this user. So we'll just change from KRBTGT to that Tamika account, and voila, able to dump out. So basically we have full access to dump out every user's password using DC sync once we manage to obtain the TGT of the domain controller. And that brings me, that's why I said because of time, I was trying to, I actually rushed through a bit because of issues with the machines. But in essence, that's what I wanted to showcase for today's session. Let me just jump into the chat and see, do we have any questions? There's none on the chat. Anyone wants to ask a question? Jones, Michael? Does that mean we're good? Amused, okay. If I may ask, what has amused you? Can feel free to unmute and speak. Can all these attacks be performed? Yes, they can all be attacked used through a C2 channel command and control, not necessarily just Covenant. It's any command and control framework, even Metasploit. The reason I'm showing it to you in native PowerShell or like on disk is basically for you to understand the things, but we all know that you can run .NET binaries. So Rubius is a .NET binary. So with certain command and control infrastructure, for example, Metasploit, Cobalt Strike, Covenant, Sliver, they all have the capacity to execute assemblies in memory. So you don't have to copy Rubius like I did to disk and run it from there. You could run it directly from memory with the same command syntax that I've used. Any other questions? Okay, I guess we have 3 minutes before the session is supposed to wind up. If we don't have any questions, then we can wind up earlier. Jones, Michael, are you there? Hello? Michael, you're there. So should I just end the session or? Okay, thank you all for joining. Whoever was here to the end might have been boring to some. So I hope to improve. If you have any questions, we can, if you have any questions, you can reach out to me. I'm on Twitter, I go by at Amarjit underscore Labu. And feel free to reach out to me and I can assist you however possible based on the previous, what do you call it? Uh, oh yeah. So before I end, Jones, for you, since you did the lab, let me just show you how I set up the, what do you call it, the unconstrained delegation, so that you can do this whole abuse path. So let me log into server. So so under machines, I'd added this server 01, which is the server 2012 machine. And to set it up for unconstrained delegation, you simply come to properties, come to delegation, and enable trust this computer for delegation. If we were setting up constrained delegation, then you use the trust computer for delegation to specified services. Remember, constrained meant that we can constrain it to a particular service that's running on the machine, whereas the trust this computer for the delegation to any services, it means you've set it up for unconstrained delegation, which is the attack primitive we just abused. So that's how to set it up on this side. And for us to have one of the, we didn't even really need to have the user as a domain admin on it. But if you want to do that, simply just fire up that server that you set up, go to run this tool called MMC. Let me just do it on that server so you can have this look see. Switch to that one. So yeah, this was when the firewall was blocking the coercing of the print spool attack. This is what I said. You run MMC, come to file, add, remove, snapping, local users. Okay, come to the groups, administrators, properties, and over here we can add. So for example, if I wanted to add John Doe, I can just do check names. It'll give me the one I want. I can double click. I click OK. Now John Doe is a local administrator on this machine. You can always go and remove, apply, OK, and you're done. So that's how I set that merge user as a administrator on this machine, and we could PowerShell remote directly to this machine. So with that, your lab, if you follow those steps, then your lab should be pretty much the same as what I have on my end. As I said, after adding this machine and adding to the domain how we did for PC01. Are there such recent exploits? When you say such recent exploit, what do you mean by that, Emmanuel? And as I said, you feel free to unmute and speak so it'll make things much easier. Emmanuel? Oh, these are not vulnerabilities. These are misconfigurations.
Oh,
When it comes to
okay.
So basically, what we've done right now, as you saw, these are not vulnerabilities, but misconfigurations that are there in Active Directory. So we were abusing, expecting like in a specific environment. So that's why I said the first session we used bad blood, which is a specific PowerShell script to create misconfigurations in an Active Directory environment. Because in a lot of corporates, because they're dealing with so many end users and PCs and stuff, there's a high possibility of finding misconfigurations and abusing that, then even abusing vulnerabilities like CVE based vulnerabilities. So ideally, yes, it's good to know those kind of vulnerabilities. And then there is also the side of misconfiguration, because some of these also interlink as vulnerabilities but get patched. Some of them are by design. And if it's by design, then it becomes a misconfiguration issue. So for example, using of weak passwords in an SPN is not a vulnerability. It is a vulnerability if you look at it because of the weak password used, but ideally the user put a password. So technically the service is running as intended. So for as for Microsoft, there's nothing they need to do. The only thing is you need to ensure that you use a strong password. So what I've showcased today is mainly, as mentioned, misconfigurations, vulnerabilities.
Thanks. I've gotten what you said.
Any other questions? Yes, Michael? Okay. And mind you, also, the reason, as I said, I used Server 2012 to do this was to quickly set it up without having to think of antivirus. Because again, AVs can also block some of these attacks. So that's why the particular reason I did. If I set it up with either Server 2016 upwards, because Windows Defender comes shipped in, then that means again bypassing all that. And as I said, this focus was not on AV bypassing, but on misconfigurations in ADs.
Okay,
Yep.
my question is based on the cracking of passwords. In your
Yeah.
experience, uh, do people observe decent password policies? Do they implement decent password policies, or have you ever encountered where people have used weak passwords when it comes to such like the way you cracked your password?
Yeah.
Have you encountered in the field where people use weak passwords or don't follow good password policies?
In fact, you'll be surprised how many times I've used RockU to crack people's passwords locally, at least Kenyans. That's why, even as I said, for this example, I was specifically using the RockU, what do you call it, dictionary. But as mentioned, there's I think there is GitHub repository called Seclist, which has like pumps of recent breaches. So they keep updating their password lists. So again, the other thing is you could then have these sort of repositories and use the passwords from them. Another thing you could try and do is also generate your own password list as you go along, because some of the things, as a security specialist who is trying to help a client, we tell them set up complex passwords, and some of we give them a use vernacular. I mean, I've never seen a password dictionary from the net that I've downloaded that has Kikuyu, for example. So finding a password, if somebody has used Kikuyu for their password, at least part of the string of the password, there's no way that's going to be cracked by a dictionary that's just downloaded off the internet. And then
Now I
that
get it.
comes, Yeah, so the next bit of that comes what I just showcased, that it's not necessarily a must every time that you have to crack the password. If you can get a TGT, as I showed there, you can then use Rubius to request for other services. And so basically you're doing what's called pass the ticket attack. So you have a ticket that's encrypted. You've not cracked the password, but since it contains the legit password of that user, you can relay that ticket and request for other services. So that's the last attack we did, the DC sync. We managed to get the encrypted ticket granting ticket of the domain control machine account, used that to authenticate to the domain controller with Rubius, and from there injected that ticket in memory, authenticated. We can now use that ticket granting ticket to request for any service, because now think of the TGT is like how I mentioned, when you log into your machine, that what do you call it? That encrypted NTLM hash is then used to request for a TGT from the KDC. And then from there, the TGT is what is then being used to request for services. So if you have that vision in mind, remember in that step where we are able to get the TGT of the domain controller, now we can impersonate that domain controller and request for other services on the network. And that's how we managed to do the DC sync attack, whereby we then able to connect to the domain controller and dump out passwords for particular users that we wanted. We can even dump out the entire database of users and their passwords. It's like, depends on what you want to achieve. I hope that answers your question.
Yes.
Awesome. I believe if we don't have any other questions, then we can end there. We're at 8:10 at the moment. So guys, thank you very much for those of you who stayed to the end. Thank you for the questions. And as mentioned, if you need any assistance, feel free to reach out to me and I'll try and help out however much possible. I'd like to bid everyone good night, good evening, good morning, good afternoon from wherever you've joined. Thank you.